let's talk about risk. In particular, let's talk about default risk. Now, what do I mean? I mean the risk that you buy a bond and the company doesn't pay you back. The company goes bankrupt. That's bad news for you as an investor, but that's also bad news for the economy. So as an economist, we want to understand how much default risk is there in the economy. One way to do that is to calculate the credit spread. The credit spread is going to tell us how big are default risk premiums, and we'll learn that based on bond market interest rates. All right, to see how that works, we first have to remember what determines a bond yield. Now, lots of things, of course, but the big picture is risk. What risks in particular are captured in a bond yield? Well, let's try and remember. We could broadly write a bond yield as the yield to maturity equals the risk-free rate plus some set of risk premiums. Now, what determines those risk premiums? Let's see if we can break it down a bit. We have things like expected inflation. We have something called interest rate risk. That's not a problem if you hold the bond till maturity, but if you decide to sell early, how much money you'll get for that bond is going to be determined by the current interest rate. And if that's different from the interest rate when you first bought the bond, you might have a capital gain or a capital loss, and you need to be compensated for that risk when you buy the bond. Liquidity risk. If I buy a bond and it's really hard to sell it to someone else, I need to be compensated for the fact that my money's locked up. And of course, default risk. What if you don't pay me back? I need to be compensated for that. Now, these risks are a little bit different from each other. If we think of liquidity and default risk, these things are very bond specific. The chance that Tesla defaults on their bond is very different than the chance that the U.S. government defaults on their bond. How liquid a loan to me, a personal loan to me is very different than how liquid Apple's bonds are. In contrast, expected inflation and interest rate risk, these things just depend on maturity. They're not bond specific in the sense that default and liquidity risk are. They're determined by how long until the bond matures. Both the Tesla bond and the U.S. government bond are exposed to inflation in the exact same way, however long until maturity is. All right, that's going to play into what happens when we calculate out a credit spread. So let me show you. A credit spread is just the difference in the yield to maturity of two different bonds, with two caveats. Number one, the bonds need to have the same maturity. And number two, one of those bonds needs to be default risk-free. In practice, we'll call that a U.S. Treasury bond, or if we're dealing with European bonds, we could do like a German government bond. We need a bond backed by a government that is very, very unlikely to default. Okay, well, if we do that, then what do we end up with? So let's write it out. We'll take our yield to maturity of our bond. Let's say it's a 10-year maturity. We'll subtract out the yield to maturity of, say, our treasury, again with a 10-year maturity. What does that give us? Well, think of all these things that make up the bond yields, right? We've got that risk-free rate, plus the expected inflation, plus the interest rate risk, plus the liquidity of the bond, plus the default premium in the bond. We're going to subtract from that the entire treasury yield, which is similarly the risk-free rate, plus the expected inflation, plus any interest rate risk, plus any liquidity risk, plus any default risk. Okay, well, let's start simplifying. The risk-free rate, we're going to subtract that out with the treasury. That'll cancel. Expected inflation is dependent only on maturity. They both have a 10-year maturity, so they should have the same expected inflation. So those will subtract out. Interest rate risk, again, only dependent on maturity, so those will cancel out. What am I left with? Liquidity risk of the bond plus default risk of the bond minus the liquidity risk of the treasury minus the default risk of the treasury. Well, the treasury by definition is default risk free, so that thing is 0. And the treasury market is the most liquid bond market in the world. The liquidity premium is going to be essentially 0 for such a liquid market. So what am I left with? Liquidity risk of the bond plus the default risk of the bond. And if I can find a bond that liquidity risk is very small, I have been able to essentially isolate the default risk premium of the bond. If that thing goes up, that means investors are demanding to be paid more for default risk, which must mean in expectation investors think that there's a higher probability of default. Okay, well, what does this look like over time? Here I'm showing you the BBB rated corporate credit spread. So I'm taking an index of BBB rated corporate bonds, subtracting out the 10-year treasury bond, and plotting that thing over time. Well, what do you notice? There's a lot of variation. Sometimes the spread is low, sometimes it's high. In particular, it's high in bad times. So look at the financial crisis there in 2008 and 2009, or the COVID crisis in 2020. You see a massive increase in credit spreads, which means during those particular recessions, investors are demanding to be paid a lot to take on the risk that companies might go bankrupt. That means they think there's a pretty high probability of bankruptcy. That should feel pretty intuitive for things like the financial crisis and the COVID crisis. And notice that's not the only time it gets high, right? The spread here is getting high around 2016, suggesting the market believed there was a real probability of companies going bankrupt in 2016. And of course, that didn't really happen in the economy. But during this time period, Europe is experiencing economic difficulties, and the market is predicting that that may spread over to the U.S., even though it didn't end up happening that way. All right, so in practice, what do we do? We're going to use a bond index rather than individual bonds. There'll be two benefits to that. One, bond indices are very liquid, so the liquidity premium is essentially 0, so that falls out, which is nice. And two, from a macroeconomic perspective, we're really interested in the aggregate risk in the economy. And so the index is going to capture that. It'll capture the risk across a big set of bonds instead of the risk to a specific company. We could do this across any credit category. Most frequently, we'll use the BBB rated corporate bond yield. In Fred, that's code DBAA. But we could do this for single B, double B, single A, double A, any credit category that we wanted to. Once we have that yield, we're going to subtract from that yield the yield on 10-year treasury bonds. We'll use what's called a 10-year constant maturity, which in Fred is code DGS10. Okay, so let's go to Fred and just do that. So here we are in Fred. Again, we want to start with the bond yield, so that's DBAA. All right, so this is the yield on BBB rated bonds. Let's go ahead and edit our graph. We're going to add some data so that we can subtract it. So here on the edit line, down here in the customized data, we're going to add to that DGS10, which is the yield on the 10-year treasury. We'll go ahead and add that. And now that we have both data sets, you'll see up here it says A is the Moody's BAA bond yield, B is the 10-year treasury yield. We want to calculate that down here in our formula box is just A minus B. That is our corporate bond yield minus our treasury yield. We'll hit apply. And there we've got it. We've got the credit spread. It's as simple as that. A super useful tool for seeing what the market thinks about credit risk in the economy. When credit spreads are high, Investors are demanding a high premium for credit risk, suggesting that investors view a high probability of companies defaulting. All right, we'll stop there, and next time we'll talk about term spreads.